Euclid, Book 1, Prop 4. If two triangles have two sides equal to two sides respectively, so this side equal to this side and this side equal to this side, and the two angles contained by the straight sides equal, then the base will be equal to the base and the whole triangle equal to the whole triangle, and the remaining angles will be equal to the remaining angles. This is known as the side angle side proof of the equality of triangles. So Euclid says, let's imagine taking triangle ABC and applying it, just putting it right on top of triangle DEF. And what we'll see is if we take line AB, which is exactly the same length as DE, and we take A and we put it on right on top of D, and we put line AB along line AE, well then these lines will begin and end in the same spot. So A will be on top of D and B will be right on top of E. And since they contain the same angle, when we start from B and we go towards, when we take BC, which is starting at E and is the same orientation away from DE, it will lie and perfectly coincide with EF. So C will perfectly coincide with F. So line AB coincides with DE, line BC perfectly coincides with EF. So the only question remaining is will the base AC perfectly coincide with DF? If it does coincide, then it's equal, because we know from common notion 4 that things that coincide are equal. Then we're done. But let's assume for the sake of argument that they don't coincide. Well, if AC doesn't coincide with DF, then it must fall either above it, like this, or below it, like this. And in either of those situations, we are saying that we can contain space with a two-sided figure. But if we take two straight lines, no matter how we orient them to each other, we can never enclose a space. It's simply impossible. That's why we don't have two-sided figures. We have three-sided figures, four-sided figures, and so on, but never two-sided figures. So it's impossible that AC will not coincide with DF. For if it did, it would contain space, two straight lines containing space, which is impossible. Therefore, it must coincide, and if it coincides, then it must be equal. Therefore, the base is equal to the base. The whole triangle, since it coincides to the whole triangle, is equal to the triangle, and the remaining angles equal to the remaining angles. Therefore, if two sides, respectively, and the angle containing between them are equal, the base will be equal to the base, the triangle to the triangle, and all the corresponding angles will be equal. Since this is a proof, this is a QED demonstration.